Cheat code solved today. So this is the problem for the day. It seems that I haven't solved it before, but the bitwise AND of an array in nums is the bitwise AND of all integers in nums. Okay. So we are given an array, and what we need to do is evaluate the bitwise AND of every combination of numbers. And return the size of the largest combination of candidates with a bitwise and greater than 0. So it seems we don't really need to find the bitwise and of all combinations, but rather the size of the largest combination of candidates with a bitwise and greater than 0. So for the bitwise and greater to be greater than 0, we need to have at least so all the bits to be 1, maybe. No, let's see. 16, 17, 62, 24. They have given this example. 16, 17, 62, 24. So it has got 1 0 0 0 0. Yeah, so the largest combination here, it seems, has to largest combination which so any combination would be greater than 0. Any combination would be greater than 0 if all the numbers have at least one common bit with all ones in it. So in that particular example, I think so this could be one example. So 1 0 0 1 0 0 1 1 1 0 0. So the MSB in all of these is 1, so therefore this combination would have a bitwise and more than 0. On the contrary, something like this, where everything, there's not a single bit which for which every element has a 1 in it, so here the bitwise AND would actually be 0. So what we could do here is just so what we could do here is just to get a collection of numbers. So first what we do is we create like a we get all the bits, all the values of the bits for each number, and then we create like a dictionary of list for every bit position which has values 1 in it, and the largest one would be the answer really. So let me create a list, dictionary of a list. Now for C in candidates, so we start off getting each bit in it, right? So let's start with first bit 0. Bit 0. Actually, we don't even need this default, we just need a counter, because we just need the counts of the elements for those bits. And now let's get all the bits for this number. I'll just store C0 as a temp copy of C. if C and 1, we increment the counts by 1 for this particular bit, then B, we increment B by 1 because we will go to the next greater bit, and we also make C, we divide C by 2. With this being done, I think that should be enough. We just need to return max of the values of counts. Maybe I'm going to get time limit exceeded, maybe, because yeah, because I'm not, oh sorry, I'm not dividing it by 2, I was multiplying it by 2. Yeah, I think this should work. See, there you go. It's the 677th day that I've been solving these problems on a daily basis. So I'll quickly summarize what I did uh, over here. We only need to look at, we for any combination which would be greater than 0, it needs to have at least one common bit which has got all ones, which is set for all the numbers in that combination. And after that, what I'm doing is I'm just maintaining a counter, and for any given number in candidates, if that number has a given bit set, then I increment the counts for that particular bit, and eventually we just need to return the max of the counts that we obtained for various bit positions. I hope this was clear and a pretty easy problem to solve. Thank you.